Yes, so let's talk about SQLite. So is anybody in the room that hasn't heard what or hasn't seen what SQLite is? Okay, you're gonna make my job very easy then. So SQLite is a database in a file. So it's very portable, it's ACID compliant, and it's in the public domain. So it's even a step above just being open source. It's heavily tested, and this thing is everywhere. It's the most widely deployed database, and maybe even most widely deployed software in the world. It's on every Android device, every iOS device. It's on my Mac. It's on Windows machines. And it's even embedded in our browsers. So for us Python developers, it's also inside our Python. The SQLite binary is embedded in every Python installation, and you can access it by just writing import SQLite 3. And then you can run queries, create databases, and all of that without installing anything other than Python itself. And because of this ease of use, SQLite is the default database for Django. So when you create a new project, the database that's going to be configured is going to be SQLite. So when I ask, is SQLite ready for production, or is it good to be used in production? This question is sort of meaningless. It is in production. It's running everywhere. If it's not good enough to run in production, then my laptop's gonna crash in the next few seconds. My phone won't work. Like, our world would probably break at this point if SQLite wasn't stable. So why do we all know? So what's so special with web applications that makes us think that SQLite is somehow not appropriate? And there is one little gotcha. So when you're running a database on someone's phone, you usually don't get 1,000 concurrent users trying to write into that database. So the use case is a little bit different when it comes to the places where you usually find SQLite and the use case that you have when you're running a production server with actual users using the software. So this is why in the Django docs, there's this sentence saying that if you're starting your first real project, you might want to choose a database that's more scalable. Even though this thing completely contradicts what's written in the SQLite docs, where it says that SQLite is probably good enough for most medium to medium traffic websites. And the number that they put up here, 100,000 hits per day, that's a huge number. Like, if you remember the charts from my talk yesterday, that's how much traffic I get in a month. So for all of my use cases, it sounds like SQLite should be perfect. And that's why when I started a new project a year ago, I decided to use SQLite to see how it works, to see if it really does make my life easier. Because I was tired of configuring a Postgres bouncer to manage connections for me. Because I just wanted a single file on my system for the database. It's just easier, it fits into my mind much easier. So I spent quite some time over the last year learning about SQLite, testing SQLite, reading the SQLite documentation, reading posts about SQLite, everything about SQLite. And now I have an answer for you whether or not SQLite is appropriate. And this answer is, of course, it depends. Yeah, I wish I had a better answer, but I will take this opportunity in the next 15 minutes to try to explain what this actually depends on. Okay, so let's start with some simple use cases. Let's say we have some read-only use case to start with. So in this example, we have gathered some data from somewhere. This data is now perfect. It doesn't need any modification at all. We just pack it into the SQLite file, the database itself, and now we can ship it to the users. We can do this in many ways. We can have it on a Raspberry Pi. We can embed it into a Docker image and have it deployed to all over the world. There are even services out there that allow you to put SQLite on the CDN edge so that it's as close to the user as possible, which means the latency is going to be tiny. This is the ideal case for SQLite, read-only use cases. If we take a look at the benchmark that I ran on a Hetzner machine that I spin up just to run benchmarks, you can see that SQLite is faster than Postgres and MySQL. It's not an order of magnitude faster, but it is faster. And this is with some configuration to make sure that Postgres doesn't open a new connection every time that you create a request. So there were some optimizations done to get the numbers as high as they are for the other two databases. And this is SQLite out of the box, no configuration, nothing. So my relationship with SQLite at this point entered the honeymoon stage. It seemed like everything is possible, that we're going to have an amazing time, and this is the best solution ever. And then I decided that maybe my data isn't perfect. Maybe users need to change it from time to time. In other words, had to start writing into the database while it was deployed somewhere. And now the big thing with SQLite is that writes block the whole database. There's no per table locks, no per row locks. It's just you block the whole database every time that you make a write. And if you don't tinker with any configuration, this block not only blocks other writes coming into the database, it also blocks reads. So when I ran a read and write benchmark, so not just read requests now, but also 10% of those requests were writes, the number of requests per second tanked. We were doing more than 2,000 requests per second with a read-only benchmark, but now we can't even get up to 600. So that's a huge reduction in performance right there. Now there is a way for you to improve this. You can unblock reads when writes are happening by enabling the write ahead log. So you run this pragma command, and then every write that comes in doesn't get saved into the main database file, but instead there's a journal file that gets created, and that writes start writing into. So at that point, you can have writes coming into the database and not block reads. And that improves the benchmark by 2x. So now we're back at in 1,200 requests per second. And yes, I've mentioned this before, but you're still going to be stuck with one concurrent write per database. And if we compare this with with Postgres and MySQL, we can see that when we just make writes, no reads this time, the performance of SQLite is never going to be as good. Like the primitives that you have in Postgres and MySQL are just going to work better when it comes to just pure writes. But I would also like to point out that even while we're doing only writes, SQLite is still doing like 600 requests per second. And that's a big number. And I bet if I rewrote this benchmark that was using Django as the server into a compiled language like Go or Rust, this number would increase. So the bottleneck here isn't SQLite itself. It's the combination of SQLite and Python. So if you really want to gain more performance, you're probably at this point better off rewriting your application in a different language. And nobody wants to do that because we all love Python. So in this case, my relationship with SQLite has moved on to the next phase. I call it the transitioning phase. This is where you know that SQLite isn't perfect. You know it has some problems, but you still think things are going to work out. Everything's going to be fine. And then you start thinking about transactions. So I added transactions to the application that I was working on to make sure that I don't get partial updates or, to have my data properly secure. And then I started getting these errors. Database is locked, operational error. Database is locked. So this makes sense. If you have a write lock on your database, and then you have another request that also wants to get that write lock, that second thread is going to have to wait a little bit. It's going to have to wait a little bit for the database to get freed up, and then it's going to try again. Okay, no problem. And if this other thread has to wait for too long, like more than 5 seconds, which is the default timeout, it's going to raise an error. Makes perfect sense. Okay, the proper solution to this problem, right? Increase the timeout. Okay, all is fixed. Nothing is going to take this long. This is a huge number, and this is in seconds. I don't even know how long this is. Still this error. What the hell is going on? And at this point, the relationship was in a real crisis. I didn't know what was happening. I didn't understand why I was still getting this error. All of the transactions were fast. Nothing took more than 1 second. And things were still timing out. I was even thinking about other databases. So I know it's Friday afternoon. This is the last talk. And to understand the problem that I was going through, we kind of have to look at transaction isolation levels. So I might lose you all at this point, but I'm going to try to get through this as fast as possible. So transaction isolation levels are essentially, let's call them, how well do your transactions work? So if we look at the first isolation level called read uncommitted, this is like the YOLO isolation level. And with this, there actually isn't an isolation level, if we're honest. Because if you have a transaction that wrote some things into the database but hasn't committed yet, you'll be able to see those changes in another transaction. That's crazy. Who would want that? But then we go to the next isolation level, the read committed. And this one is the default one for most frameworks, at least for most web frameworks. Why? Because it solves this commit issue. You will only be able to see things that were actually committed, but you still have a bunch of other possible issues, like non-repeatable reads and phantom reads. But those actually, in a web application context, don't matter that much, because those just tell you that if you do the same query in the same transaction multiple times, you're going to get the same result. And if in read committed, that's not the case. But if you're doing the same query multiple times in the same request, then you probably have a performance issue. Why are you querying the same data twice? Just remove the extra query. Return the data to the user a little bit faster. Your users will be happy. So this is what most databases allow you to configure. You can pick which isolation level is appropriate for you. This is not the case with SQLite. SQLite only has the serializable isolation level. And it implements it in a way that's a little bit annoying for the developer. It doesn't mean that your code is just going to run slower. It means that it might raise exceptions, like the exceptions that I've been getting. And to see that, I can quickly demonstrate how SQLite does this. So SQLite uses deferred transactions, which means that it's going to try to defer acquiring the lock as long as possible. So we start with the begin. SQLite doesn't really need the write lock at this point, so it's going to just acquire a read lock. It's going to query the database here. And now, when it's time to do the update, this is when it goes and acquires the lock. And if there's no other transaction or another write happening, it's going to be able to get the lock, commit the code, and everything's going to be fine. But if there is something else happening at the same time, then this line will fail. And for SQLite, it won't make sense to wait until the other transaction finishes, because that other transaction might change the database. And then SQLite doesn't know. If you have another select statement later on, it might return a different result that it did right now, which means the serializable isolation level is going to not be respected. So what SQLite does in this instance, it throws an error, the error that I've been getting. And that's why the timeout didn't change anything, because you can wait all you want, but this transaction is ruined. The solution, once you understand the problem, is actually simple. You log the database before you do any selects beforehand. And there's a keyword for that, begin immediate. This, of course, has a bit of a downside, because now the whole database is locked from the time you run your first begin, or the begin immediate, until your commit. And this can, in a lot of, especially if you're now running a bunch of Python code in between, This might be slow, and it might cause problems. Now, one way to avoid this is you can have multiple SQLite files. So you put some tables into different SQLite files, and that way you have multiple locks. And that can help speed things up. But now your application code needs to be aware of this. And at this point, you're probably better off using something like Postgres, where you don't have to worry about this. It's handled for you by the database. So now that we've come through the other end of this tunnel, I feel like SQLite and I are in this partnership stage. I know what SQLite likes, I know what it dislikes, and I know how to make us both happy. So just a quick detour. There were a few changes merged into Django 5.1 that help keep SQLite happy. The first one was there's now an option for you to configure immediate transactions right in your settings.py file. This was a contribution that I managed to get merged, so I'm really happy to get that merged. It was even my first pull request into the Django repository, so yay me. And the second one was the addition of the init command that allows you to set the pragmas that we looked at the a little bit earlier, so the journal mode. And there's a few other ones that you can set if you want to improve the performance a little bit. Now, I've tried to benchmark all of these, and the only one that actually made a very impactful difference was journal mode. The rest, they were probably lost in the noise of the benchmark and the fact that Python itself adds a bit of overhead. So in summary, SQLite is an amazing database if all you want to do is read from it. You can easily distribute it, and it works really well. It also very likely won't be the bottleneck if you're just doing write-heavy workloads. Like the amount of writes that you can do on a fairly fast SSD machine these days, it can scale to hundreds, if not thousands, of concurrent users without much issue. The thing is, you do need to be careful with transactions, especially if you do them inside Python code that can run a lot slower than the C code that SQLite is written in. And remember, you chose SQLite to keep things simple. If things are getting complicated, maybe it's best to say, it's not you, it's me. Thank you.
Thank you, Andrzej, for sharing your experiences and insights. We have time for a few questions for those of us interested. I see two hands at the back. That's one. Okay. We have time. Where are we? Where are the hands? We have hands here. Okay. There you go.
Hi. Thank you for the presentation. So one question, imagine that you have a distributed, let's say, a backend server, so you have like 10 different machines, and you want to talk with only one backend instance. If it's the read-only one, then you can have 10 copies, but if otherwise, how do you handle that parallelization, let's say?
Yeah, thank you. So you unlock the secret slide. So yes, you have options for getting SQLite to work on multiple servers. I believe the most known one or most used these days is LiteFS. It's basically a file system designed for syncing your database onto multiple machines. Now, the drawback with this approach is that you'll still sort of have to route your write requests to the primary server so that then those changes can get propagated to all the others. And this is slightly annoying because, again, this implementation detail then bleeds into your application code a little bit. And so this was fly.io that implemented or that is working on LiteFS, and they have a few ways for you to specify to make it easier for you to get this to work. Like you can set special headers in your request to make sure that they get routed to the correct server, the one that has the primary. But again, you as an application developer are going to have to think about this. For every query that you write, you're going to have to say, oh, do I have to do a write? Oh, then this request has to go to this other server. And if you're doing that, I think it makes more sense to use a database like Postgres, where you don't have to think about it. It is possible. You can get this to work. It's just not going to be as convenient.
Okay, we had another question in the back here. There you go.
Hi, thank you. Great talk. I just wanted to maybe also extend this question. Like, have you tried SQLite, for example, with Cloudflare, because they have, I think, a distributed solution right now, or like any open source similar like way of doing that? Yeah, so I haven't tried the Cloudflare version of this. I imagine it has some of the same issues as Fly.io, in the sense that you can't just forget about this limitation that SQLite has, that you always have to have writes go to one instance and then propagate those down. Otherwise, you're just going to have conflicts between them. SQLite hasn't really been designed in this regard, but again, if you have a read-only use case, then I bet Cloudflare works amazingly because it just makes sure your database is everywhere in the world. So the latency is going to be very small for all the users.
And I think we had a question somewhere around here, didn't we?
More in front.
There's one in the front. There was one here. No. Where is it? Hands in the air. There was a hand here. Oh, there you go.
Hi. So about SQLite, the Rails community is moving towards a SQLite-backed caching system and queuing system. Do you see like the Django community going towards something like that? Like you said, with the way the SSDs are now faster than, sometimes not faster than RAM, but almost at the same pace as we have in our systems now.
Yes, so congratulations. You have also unlocked the secret slide. Yeah, so like you said, the Rails community does have what they call LiteStack. It's essentially a whole set of applications that run on SQLite. So you have your full text search database, your, of course, relational database, and even your task queuing and management database, as well as caching. All of that built using separate SQLite instances. Now it can work, and I don't think the Python, or at least the Django community, is going to build, we're not going to build our own LiteStack. It feels like it's a little bit too risky to put all of your eggs into a single basket, even though it might simplify things in the short term. I would say that, I don't know, you really have to be sold on the idea that SQLite can, for sure, handle all your use cases for your, I mean, for personal projects, sure, that this can work well. But at some point, probably, you will want to have multiple servers running, just so that you can apply updates without worrying that everything is going to go down. So I don't know, I mean, I'm a fan of SQLite, but I don't think I would actually want to go that deep into this myself. I am, of course, keeping an eye on this because it is super interesting, and I really want to see how far they manage to get it.
Okay, and I think we have no further questions, so please let's thank Andrzej again with a warm round of applause.